Good afternoon, everyone. Just one thing. The single worst time to approach me is right before I set up the stuff, because there are like 17 different things that all have to work out just so for the lecture recording and everything, and so it's a high stress time for me. So don't do it. All right. So let's simply get started with. Well, I should ask. Does anyone want to ask any questions? Yes. I'm sorry? Okay. Yeah, but unfortunately, all I can do is share your pain right now. We'll have to have a look at it later. Any other questions? Yeah. A bunch of people got an email from Canvas saying that they didn't do the quiz. There's some glitch in Canvas. So if you did the quiz and you got the email anyway, just ignore it. A bunch of you replied to me, and I tried to reply as much as I had time. So sorry about that. I'll find out why I did it. Other questions? Yes? Is there another lab class? There will not. Well, the lab section 15 has opened, but the sections are what they are. Those of you who wanted, some people sent me an email that they wanted to switch sections. I'll look at those emails tomorrow. So tomorrow I'll make another pass through the waiting list. I hope I'll be able to add just about everyone. And there might be a few Open University students who are still at the very end of the waiting list. But I think it'll work pretty well. So wait till tomorrow. If you had any change requests, now would actually be a good time to email it to me. Other questions? Yeah. So you got to add it into the wrong section? You have to send me an email today, and when I look at all of that adding stuff tomorrow, I'll hopefully work it out. I might have to send you another add code. Other questions? Yeah. The last question, that was the one with the spelling error? Yes. Okay, so the question is it a so the question was system.out.println, and then it misspelled welcome or some such thing. And so there's really three reasonable answers. Is it a compile time error? Is it a runtime error? Or is it no error at all? And so it's not a compile time error because the program compiles. The compiler doesn't know English, so it doesn't care what's inside the quoted strings. Now, is it a runtime error or isn't it? And you could argue maybe that's what the person intended, in which case it wouldn't be a runtime error. Or you could say, well, it's an error. It's obviously not what was intended, and therefore it's a runtime error. And now both of those, could be construed in a court of law as reasonable answers. Yeah.
I understand why compile error is synonymous with syntax error, but what is the significance of runtime error?
Well, the difference between a compile time versus runtime error is where does it manifest itself? Does it manifest itself when the program runs, or does it manifest itself when the program is compiled? So there's some errors. For example, when you forget a semicolon or the closing quotation mark, the compiler will catch those errors.
That's a syntax.
And so all syntax errors are compiler errors, yes. But there's some errors that are not just rules of the syntax of the language. A semicolon is an issue of syntax, but there's some semantic errors that the compiler will catch. There's some things that where you do something wrong that's syntactically correct. The semicolons are all at the right place, but the semantics are wrong, and the compiler might catch that. So that's why I prefer to break it down as compile time versus runtime errors. So there are compile time errors that are not just syntax errors, that are at a somewhat higher level than that.
For a while, I thought they were synonymous.
Someone out there will say, I always consider them synonymous. But I think compile time versus runtime is an unambiguous thing. Do you find the error as the program compiles? Do you find it as it runs? So I think that's an easy distinction to make without having to get into any minutia. So to get back to the question here, is it an error at all or is it no error? And you're going to have to keep in mind this is a multiple choice quiz where you have to pick exactly one answer, and so you're going to have to kind of pick the best answer because you're not in a court of law, right? You're in a court of canvas and have to check one answer and move on with your life. And now the book has a similar discussion where it talks about some misspelling in Hello World, and it says this is misspelled. It's a runtime error. And at that point, you should just go and go with the flow and say, well, obviously that's a very similar situation. So there will be situations with these quiz questions where the poor fellow, I mean, just think of the poor fellow who had to write these quiz questions. In chapter 1, it's particularly hard. There wasn't a lot of material. He or she had to come up with 75 different questions. And so clearly that person just looked through this section of the book and just came up with that question. All right. Any other questions? And next time what I'll start doing is I'll invite you to put some questions up on Piazza. That way you don't have to shout them through the room, and you might find that, particularly if there's some code involved, more pleasant. So let's get going. We are in this lecture here. So did you take the quiz? Well, my intent was to get Canvas to bug you if you didn't. So we're going to be learning Java. So why Java? It's simple. I think most of you are going to agree that most of, once you get into it, that most of Java is pretty simple. But there are, I must admit, a few issues that are bothersome for beginners, and I'll try to beat some of them down. But as a language for getting into computer science goes, Java is mostly pretty simple. There are languages that are quite a bit more complicated. Those of you who have done some C or C++, for example, will agree after a few weeks that they're way more complicated than Java. It's safe. And why do we care that it's safe? The reason I care is that when you make a stupid mistake in a C++ program, your program will run in some flaky way, and it will run differently the next time around. And it might sometimes crash and sometimes not. And it's very confusing for a beginner. They made a mistake, which you all are going to make lots of those, and you can't really tell with precision. Java, on the other hand, because of the safety features, if you make a mistake, the virtual machine will find it, it will kill your program with extreme prejudice and say, line 17 had this mistake. And that's great, because then you know that you have to look at line 17. And so that's a huge advantage of using Java, that you get that very precise information on where mistakes happen. And it's a byproduct, really, of the safety features of the language. Platform independence. Why do you care? Because you didn't have to buy a new laptop. You can use whatever laptop you had, Windows, Mac, Linux. They all run Java, and you can just do that. Whereas there's a whole bunch of programming languages that depend on a particular platform. So if you use C#, for example, it would be more difficult. You might have to just buy another machine. The thing that I like when teaching it is it has a rich library, so you can do interesting things. For example, that Alice thing that you saw in the lab, was written in Java. They never really thought about using this as the vehicle for a CS1 instruction, but I saw this and said, this is great. I have a 3D animation system for free that I can make you write some simple programs with. And there are other third-party libraries that make it a good teaching language because it makes the assignments a bit more interesting than just printing out letters and numbers. And, of course, they're great tools. There's probably better tools for Java than for any other programming language that anyone has ever seen. For education, there's this BlueJ environment that I'll be demoing today and that you also saw in the lab. BlueJ is very, very nice for beginners. And so it'll get us through most of the first semester. Towards the end, we're going to transition over to using NetBeans full-time. NetBeans is much better for experts. But you have these two environments and many, many others that, that are really very, very nice. So ever so often we say, should we move to a different programming language? But there's none that has these advantages. So let's look at our first program, just because it's a tradition. So the tradition in computer science is that the first program in any language that you look at, and you're going to be looking at many languages during your career, that the first program is the one that prints the message, hello world. That tradition was started 30, 40 years ago by people, and we still do it. So here's that program, and it has a bunch of parts that I'll be calling out. So first of all, when you look at this program, an important thing is you need to focus on the important stuff, and that is everything that is inside main. So here you see the main method, and all of the stuff that's outside main, don't look at it. That's all boring stuff. For the first couple of weeks, certainly for the first week, looking at it that way is going to be helpful. Just ignore everything that's outside main. It also means if you wanted to come up with some other program, say someone forced you to write a program, goodbye printer, what you should do is you should take this thing here as a template, copy and paste it, and don't even look at the other stuff, and just modify those things that you obviously need to modify, like change this hello to goodbye, and I guess, just change this hello to goodbye, and you're good to go. So every Java program has a bunch of stuff that we're not really interested in right now, and it has the stuff that we need to look at, the thing inside main. So system.out.println is a magic incantation to print something on the console. I'll be running this program in just a minute, and you see where it prints. Why is it called system.out.println? Let's not worry about it right this minute. It's just the magic incantation that you need. Inside here, you see the string hello world. Now, notice a string. It's text that's enclosed in these double quotes, and everything that's inside double quotes, the compiler does not care about. So it just passes the string on to the println method, and you could put in anything that you want. You could put in Java is dumb, and the compiler would not be insulted. Everything that is not inside double quotes, like all of this stuff here, public class, public static void, that you have to type just so because the compiler will look at it. And even to you, the words public, static, and void have no meaning. The compiler cares greatly about them. So if you misspell them in any way, you're going to get an error. So let me just run this thing. It'll take me just a minute to set this up. Bear with me here. So here's BlueJ. We'll make a new project. Now I have to put that project somewhere. So find my way to my home directory. This machine is in home Chi. Now I made a directory San Jose State 46A. And here I'm going to make a new project that I'll call hello. Okay, here it goes. I make a new class. Yes? Yes.
So when you name the project hello, that isn't the name of the class?
That's correct. The project is just a container for one or more classes. For the first week or two, we are only going to have a single class. But pretty soon we're going to have lots of different classes, and they all have their own name, and they all still need to be in a project. And the name of the project is entirely arbitrary, so you could name it like Homework 1A or whatever. But the name of the class, that has to be just so. So for the name of the class, I have no choice. I do have to call it Hello Printer. All right, so here's my class. It's filled with a bunch of junk. Just get rid of it, Control-A, delete it, or Alt-A on the Mac. And now we paste in the thing that we want from here. All right, click on compile. And it compiled with no syntax errors. Notice what I did not do. I did not type it with my own hands. It would be foolish to do that, because if you type this thing with your own hands, you're going to be introducing 3 or 4 silly little errors, and it's going to take you time to fix them. So the first thing that I always think about when I start a new project, I say, what is the most similar project that I already have on my hard disk? And I try to copy that as much as possible, and then I just rip the stuff out that I don't need, and I add in the thing that I do need. So let's say that I'm supposed to print goodbye world, then I can just type it in here. And
it still can be in the public class hello printer.
Yes, because the Java compiler has no conception of what this thing does. So now I'll compile it. All right, now I need to run it. To run it, you right-click and you run the main method like this. And now here you see the output. Right. Now, of course, it would be kind of nice to rename it, and there must be a way of doing that. Unfortunately, there isn't. I have to make a new class. I'm sorry? Okay, let me do this slowly. So I'm right-clicking on the class name, and there's a bunch of options. And the only one that makes sense to us today is this one here. We'll see in a couple of lectures, or maybe even the next lecture, what this option means. But today we're going to be running main. So you click this main thing. Then you get a mysterious thing here. You just click OK. Don't even look at it. And now it runs it again, and it prints it again here. Now, personally, I find it confusing that it keeps on adding to the terminal because after a while I forget what was there before. And so I turn on this option that says clear screen at method call, and you'll see what happens when I run it for the 3rd time. Then it first cleared the screen, and I know now this is the run of my program. On the other hand, if you like to keep a record of the past, then you could leave that option unchecked. All right, so now what do you do if you do want to rename the class? Unfortunately, when you right-click on here, there's no mechanism for renaming the class. And that's because this is just a training wheels environment. They try to keep the number of options very small. So the way to do this here would have to be to make a new class, goodbye printer. And now I'll just have to copy this stuff here. Open the editor here, delete what was there before, paste in here. And now, of course, I have to change the class name. Let me just see, what if I don't change the class name? Now when I compile, then I get some nasty error message that says it already exists. All right, so let me change this. So that says goodbye. So I have to turn it off. And now when I compile it, it's all fine. And now I have these 2 classes here. You can have as many classes as you like inside a project, but it's a good idea to only have related classes in a project. Sometimes I see students that have a project called Lab 1, and it has the entire life history worth of classes in it. And that's not such a good idea, because you can't rename them. You can't have multiple versions of, say, a bank account in the same project. So try to keep a project for a specific purpose. All right. Back to the slides. So I'll tell you a little bit about what each of these keywords means so that you have a basic idea, and that idea will refine itself over time. So you have this keyword public here. There's a way of hiding stuff in Java that we're not going to be doing for a little bit, so right now it's public. Public seems good. Class is it's one of the more mysterious things what a class is. Right now you should think of a class as just a container for the code that does some stuff. A class has to have a name, and that name should be related to its purpose. So in your first homework assignment, you have one class called Animal Greeter and one called, I don't remember. Does anyone remember?
It was like rabbit
Yeah, exactly. It was the square grower or grow square or whatever. And the third one was called Homework 1C because I couldn't think of any better name. So each class has to have a name. The name of the file must exactly match the name of the class. So hello printer must be contained in a file helloprinter.java. Now when you use BlueJ, you don't really need to know about that aspect of it because it makes the files for you. When you click on the new class button, it makes the Java file for you. I'll show you in a few minutes where that file is. Now, every Java application, every Java program needs to have at least one class that has a main method, and the main method always looks like this: public static void main. And so public is whatever, it's lots of people can see it. Static means that when you touch it, it kind of sticks to you. No, I don't think I'll ever explain why it means static. It's a very strange keyword.
You mean it stays the same?
No. It's called, there's a long history. In the C language, static meant something that sticks around. And then in C++, they didn't have a keyword to describe an unrelated feature. And they didn't want to introduce a new one. They said, oh, this one isn't used very much. We'll just use it for the same feature, even though it makes no sense whatsoever. Then Java came along and said, oh, we're just going to do it the same way as C++, because, of course, everyone knows C++, and that way they don't have to learn anything new. That was a bad idea because, of course, at the time that Java was born, most people, no one knew anything about Java, and everyone who was going to know something about it was still going to be born. And now the upshot is we're stuck with a essentially gibberish keyword, but that's life. So right now, just don't worry what static means. Void means that this is a function or a method that doesn't compute any answer. It prints something out, but it doesn't return anything, and that'll start making more sense in a week or so. Main, by convention, the entry point of any program, the first method that gets executed is called main, and you have no choice. The execution starts at main. This gibberish inside here is going to make more sense to you in probably 12 weeks. So right now, you're just going to have to copy and paste it. This is one of the criticisms of Java, that the person on day one is forced to accept a bunch of gibberish. And I have no better advice for you than to just accept it and just copy and paste it for a while. So every method has this entry point. It's always exactly the same, and you can just copy and paste it. And over time, we're going to understand what the pieces mean. Now, the first line inside the main method, that the thing that starts with the 2 slashes, is a comment. And so you can put anything that you want inside a comment. So in here, for example, right now it says display a greeting. I guess I could change this to be more accurate. Now the compiler completely ignores everything that you put inside these comments. They're just there for the human reader. Yes?
Aren't there supposed to be those slashes on the other side of the comment as well?
No. If you put 2 slashes here, that's good enough. So,
And then you just start a new line after.
yeah. So, like, say I want to have a comment like this. I just put it like that.
Okay, just as long as you end the line after that.
Yes, it goes from the point of the 2 slashes until the end of the line. You can put a comment even after a line of code, and that also works, from the slashes until the end of the line. If you want to have a very long comment, you have to use different delimiters, and they look like this. I'm going to find on my keyboard here. So here you have a long comment that goes over many lines, and for that you need to use this. So this particular program, BlueJ does or give you a neat little column of asterisks. You don't strictly need these asterisks, but hey, if you could take them out, but if you get them for free, why not? I mean, I would never type them in by hand, but if the environment gives them to me.
That's the minimum.
Yes, that's the minimum that you need, what you see right here, if you have a multi-line comment. Now again, notice that the compiler doesn't read the comment, so you can put in and it'll not be insulted, right? It'll still compile. So, so these are just there for human consumption. Okay. The body of a method is enclosed in braces. So going here, let's make this a little bigger. Notice the brace here and the brace here. And everything that's between the braces gets executed. You can have as many instructions here as you like. So far we just know how to print, so I could put another instruction here. And then they would both get executed when you run this program.
And those would be like 2 lines of text.
Yes. So now we'll see in just a minute. Here now you see it does 2 lines of text.
I have a question.
Yeah.
Are they both executed at the same time, or are they one after the other?
Well, one after the other. The program gets executed from the top down. And so it first executes this call, and after it's done with that, then it moves on to the next.
Got another question.
Yeah.
You have two names in the same class there?
No, I have 2 classes, each of which has its own main. So this fellow has a main, and this fellow has a main. And I can execute both. I can execute this one here, and it'll just say this because I edited it before. Let me actually, to make really clear how different they are, I'm going to go back to Hello World in here. Compile it and run its main. And its main says Hello World.
Yeah, I'm noting the way it's visually laid out. You've got the total class goodbye printer, and that will outside is green, and then inside you've got that really sounded
Yeah.
main. Yellow. Can you fit more than one?
You can put other methods in here, but we don't yet know how to do that. So right now all we know is how to do the main method, but I could put another method in here. And let me type the closing parenthesis. You want to line them up. So then I would have more than one method in it. We're not going to be doing that for a little bit. Yeah, but it tries to help you out to see the nesting structure by giving you this color coding, which is kind of nice. All right, where are we? Okay, so the braces here, they are there to group stuff together. So far, there's only one thing that we need to worry about grouping together, and that's the stuff inside main. The semicolons, they're kind of like punctuation marks in English. Every sentence in English ends in a period, and every sentence in this programming language ends in a semicolon. What happens if you forget the semicolon? Let's just try it out. Then you should get an error, and hey, this error message is actually pretty good. It says semicolon expected. Not all error messages that you will see are this good. So that is a powerful clue to put the semicolon back in. All right. Notice that if I make a punctuation error in here, then the compiler has no idea because that's just text that the compiler doesn't look at. Yeah?
Sometimes when you render the program on your Windows, you show runtime error. But if it's a logical error, how can the system know?
Well, the system doesn't really understand what's a logical error. A runtime error is an error that happens in runtime. And so if you get some kind of box that says something went wrong, then something went wrong. Your program touched some memory that it wasn't allowed to touch maybe. Or it tried to access some part of the file system that didn't exist or that didn't have permission for. So again, I'm trying to steer you away from the syntax versus logic error that you sometimes find in books, because there's so much disagreement of is it a logic error, what is it? Whereas runtime error is it's an error that happened as the program ran. And there could be 2 kinds of errors. There could be the kind that where the program behaves wrongly, or where the program actually throws up scary dialogues. But then again, if you try to make that distinction, that also is a wrong behavior. So I'm just going to talk about compile time versus runtime errors. All right, back to this program here. So over here, you see what's called a method call, system.out.println. So let's look at that method call in a little bit more detail. So first of all, what's a method? That's another one of those kind of irritating terms that in math you would call it a function. It's something that does some particular job. And in Java, for historical reasons, they call it a method. So you should think of a method as something that knows how to do a particular job. The job in question here is to have stuff show up on that little white window. What's that?
Basically means print line.
Yeah, it should print a line of stuff. That's the purpose of the method. Now, when you call a method, it needs to know things. Like to print a line of stuff, it needs to know what it is that you want to print. And you put that what it is, that input to the method, you put it inside the parentheses of the method call. So every method call has an opening and a closing parenthesis. And between those, you put whatever information that method needs to operate. Now, in our case, it needs to know the hello world string. Later, we're going to see other methods that need numbers or whatever. Now, it gets a little bit more complicated than that, and that is that in an object-oriented programming language such as Java, there is a fundamental belief that says whenever any work is to be done, there needs to be a single responsible entity, the so-called object. So everything that's done in Java is done by some object. And the object that knows how to print stuff on the output is called system.out. Just like I'm called Kai Horstman, that thing is called system.out. It's a bit of a funny name, but hey, Kai Horstman is a bit funny too. So just get used to it, that it's its name, and you need to call it politely as system.out.
Is it specifically for putting print on the monitor?
Yes, system.out has a single mission in life, and that's to make stuff appear on the console. That's all it does. Now, system.out knows a few methods. One of them is println. Println prints something, and then it makes a new line afterwards so that the subsequent output shows up below it. There's also a method called print without the println that prints, but it doesn't make a new line. So let's just run this, and you'll see what it does. You see there's no separator between the first and the second line. And sometimes that's useful. But the upshot is that system.out knows to do more than one thing. It can print or it can print on. It also knows a couple of other things, but those are the ones that are of interest to us right now. So system.out is the object. It has a bunch of methods. Here we're calling the println method. And the method gets these inputs, or as they're called, parameters. You put the parentheses, you feed the parameters inside, and then your method call is ready. All right. Strings. So anything that you put inside quotation marks is a string. And you can put in what you want, and that thing is then going to be output or manipulated in some way. Now, a very common error is to forget the closing quotation mark. In this case, let's see what the compiler does. It says, okay, system.out.println, that's the method call. It sees this and says, oh, a string is starting. That string contains goodbye, cruel world, the exclamation mark, the closing parenthesis, the semicolon, all of this stuff. And then it says, whoa, that string goes on all the way to the end of the line. That can't be right. Let's see what error message we get. And it says, unclosed string literal. A literal is something that you use in a program to denote a specific value. For example, later when we use numbers, we might put the number 2. And we literally mean the number 2. That's what's called a literal. So this one's called a string literal. It's a bit of jargon. So then that tells you unclosed means you have to come up with the closing quotation. And then it'll work. All right. So now we'll do something exciting and different. We'll come up with our first clicker question. This is what you must do. You need to log into Piazza, and I will do the same. Okay, I will now make a new question. This is my course. Yep. New post. I will make it a poll. I will make 4 choices, 1, 2, 3, 4. And it's not anonymous. Yeah? What's that? Yes, you will get a point if you get it wrong. Absolutely. Absolutely. All right, so here's the question, and it says 1, 2, 3, 4, and here you can see what it is that I'm asking. So I want you to have a look at this program, and I want you to tell me, what does it print? And I want everyone to do this, so Piazza will tell me in a few minutes exactly how many results there are. So hopefully they will start trundling in. What's that?
Well, I'm getting kicked off the internet.
Yeah, okay, I'll look at that in just a minute. Hopefully some of you will log on. So let me have a show of hands. Who is not able to log on? That's all right.
My internet connection was doing fine a few minutes ago.
Okay.
There we go.
Yeah, it's fine. No. No, not the AV. The AV is the internet. Our all right. See if I. Yeah, I mean it'll take a bit. And just as a hint, in the future, what you should try to do is log on when class starts, because every class will have a few of these questions, and
Yeah, but it doesn't work when it kicks you right back off the internet.
right. Well, we have to get it to work. Some people will just give it a few minutes. Okay, well then that's good. Same with you.
Well, yeah, I'm halfway off. I have to disconnect and log back on. I don't know what's going on.
I've never done it. You know what? I'm not. Ah, okay. Okay, so I have a total of 83 votes. There was a question? Yeah?
A couple of weeks ago, they combined the SES Street Air and the National Campus applications.
Yeah.
So a lot of people think it's a premier campus, so everybody's loading on the regular campus one, and so
Okay, so the upshot is if the Premiere doesn't work, what's the try there?
well, that's everybody is. It's overloaded.
Okay, well, we'll need to make sure we'll get a technician here. All right, well, in the interest of time, so here we have kind of this is just a warm-up thing anyway. So here we've kind of a typical outcome. We have 80 people, and we can see who they are, in fact, who answered number 2, and that is, in fact, the correct answer, because it prints hello, and then in a new line it prints world. So number 1, I was trying to trick people and say, well, gosh, maybe someone out there thinks that the comment here will also produce an output. But I didn't manage to trick a single person, so that wasn't so good. I did manage to confuse a few people who thought, for whatever reason, that it printed them in a single line. And those people, now you know it doesn't. And no one thought it printed something else. I often put a something else to protect myself against typos on my own slides. But sometimes the answer really is something else. So we're doing these things here, and there's a whole bunch of them every lecture, so you really do want to get your laptop so that it does work out. Piazza loads a little slowly, so it's a good idea to load up Piazza before the class starts. That way, hopefully, it'll stick around. Yeah?
Tyler ignores them, but doesn't have to process them.
No. The very first thing that the compiler does is throw them away. All right, so the reason we're doing these clicker questions is that research shows that the average student will zone out from the lecture after 19 minutes. And that one needs to do something to get students to do something after those 19 minutes so that they start paying attention again. And so these things work really super well for that. They're called clicker questions, and you may have that like in some other classes, because traditionally one used like an infrared device. And those work fine, except the devices are like $30 or so. And I didn't want you to buy one just for this class, since you all have a laptop. So hopefully we'll get past these network issues. All right, a bit of jargon for writing, compiling, and running. So the thing that I use here to type up my text is called an editor. I can edit my code, add things, move things away. And then stuff gets compiled. That happens here when I click this compile button. So there is a little piece of software behind the scenes that takes my text and translates it into what's called virtual machine instructions. And behind the scenes, it makes a file with extension .class. You'll see those files, and when the time comes to submit your homework, and the thing to keep in mind is don't give me the .class file, because I am not a virtual machine. I wouldn't know what to do with it. The .java files, they contain this stuff. I can read it. I can, if I so choose, compile and run it. The .class files are only good for the virtual machine. Let me actually show you these files real quick. So here's my home directory, SJSU, CS46A. Here's that hello thing that I just made. And here you see a whole bunch of different classes. Here's helloprinter.java. Let me look at it just with a text editor. And here's what it looks like. You see it contains plain text. Let's look at helloprinter.class, also with a text editor. Okay, well, I'll open it from the text editor. And it looks like this. Well, so if you email me one of those, I'll say, well, there's nothing I can do with it. There's just a bunch of gibberish in there. Don't email me those, okay? This one, good. This one, bad. All right. There's a few other files here. There's a helloprinter.ctxt. Let's see what's in it. And it has some stuff that BlueJ wants internally. Me, I'm not BlueJ. Don't send it to me. Okay? All I need is this one. There's another file called package.bluej. And I've seen people who send them to me. Let's see what's in here. More BlueJ stuff that BlueJ wants for its internal happiness. I don't want it. And then there's a readme.txt. Let's see what's in it. This is something where you could, if you so chose, do some documentation for the project, but we're not going to be doing that in this course. So the only file that I care about is the one with extension .java. See, this one he has extension .java. This one he has extension .java. Now, in Windows, I'm sorry to say that by default, Windows is configured not to show you the extension. So in Windows, when you look at this directory, it'll say, goodbye printer, goodbye printer, goodbye printer, hello printer, hello printer, hello printer, package, and readme. This is known as stupid. So in Windows, they don't want to show you the extension because they're under the mistaken opinion that an extension, the concept of that little thing at the end of the file that tells you what kind of file it is, that would be confusing. If you were confused by such things, you would not be in this lecture. So you want to make sure that your Windows is configured so that it shows them. And I believe in the lab I indicated the magic path to do that. You have to, somewhere you have to find the right thing and click the, you have to unclick hide known file types. And that's actually important for you because when you submit your homework, you're going to have to pick those files and you really want to pick the right ones. About 20% of people at the first homework get 0 points and their crime is simply to submit the wrong files. Well, if you can't even see the files right, then that is particularly challenging. So make sure that you submit the right files. The files that I want to see are those Java files that have the public class in there. I do not want this. I do not want any of these. Okay? So you submit 3 files for the homework, each of which kind of looks like this. Public class, whatever, public static void main, stuff inside. Those are the classes that anyone then can give to the Java compiler, can compile, and then it makes those class files that we don't really care about. That is some intermediate product, and then the Java virtual machine loads those and executes them. Now in BlueJ, the way to load them is to right-click on this thing here. So when I click on main, then the virtual machine gets loaded, and it does the execution. And the fact that it reads the class files is kind of immaterial for you. Really, the only reason you need to know about those files is to know not to submit them. All right, so you can look at this picture yourself. Errors. Yes, we did. Can we not have another show of hands? Who didn't manage to get on the internet?
I had to actually reset my machine.
Okay, so about 10%, I think, are unable to connect.
Okay. I'll help out tonight.
Okay, thank you.
I think that it's because like you have to shut it down and let it sit for a couple seconds and reset the router.
What I always tell them is I want it to be like at Starbucks. You know, you go in and you connect to the internet, and that's what they need to do. Yeah. So. No, it's going to take a couple of weeks to get it all straightened out, and eventually a more important-looking person will show up and sagely shake their head, and but then eventually it will get fixed. That's what happened every semester. All right, errors. So we distinguish between compile time and runtime errors. Compile time means the compiler finds it, like over here where I forgot the closing quotation mark. Runtime error means it's only detected at runtime, hopefully detected at runtime, maybe never detected by anyone. It occurs at runtime. So here, it prints the wrong thing. Or over here, when you divide by 0. Let's actually see what happens when you divide by 0. So over here, let's print this. Let's compile. There's a hello printer. And now you see that an error manifested itself at runtime, and it says here java.lang.arithmetic exception. An exception means something very bad happened when the program ran. And here the exception is /by0. So the program died, and in fact, let me demonstrate to you that it really did die. If I switch the order of these two, and I'll compile, and I'll run. Notice there's no output this time. So that means this statement here got executed. Bad things happened. Your program was killed, and it never got to the second line. So that's a typical example of a runtime error. Bad stuff happens, program gets taken out of commission. Yeah?
Wasn't that considered a compile time error? Like, if you press compile.
Okay, let me demonstrate that it's not a compile time error. Okay, watch me click this button. Okay? So, compile time error means the compiler complains. Runtime error means bad things happen at runtime.
So in this case, a syntax error was a runtime.
Well, I don't even want to get into the philosophy of is this a syntax error. All right. So let's have a more interesting clicker question here. Let me put this up here. You know, it helps if you can read this on your own screen while I do my quick Piazza setup here. New post. Poll title. Poll choices 1, 2, 3, 4. Clicker. Give me clicker. All right.
Oh, me too. Except this is a Piazza there. Yeah, I think we get it. Oh, there it is.
All right, let's have a quick peek at this here. So we're just going to have to look for syntax errors. And it looks like if we look here, there's a syntax error. What's the error? There's no slashes, right? There's a missing comment here, so that's bad. So that eliminates this option here, and certainly also eliminates this option, because if it can't compile, it won't ever run. So then let's see, do we find a second error? Yeah. Over here, there's an unclosed string. So that means the answer is 4. Let's see how people were doing with it. And once again, I didn't fool very many people, but also didn't get very many answers. So there's like well over 100 people in this room. So you really need to get into the swing of doing this kind of stuff, because you're going to get points for it. So these lucky people here all have just earned a point. And so have these. It doesn't matter if you answer it wrong. So if you're totally desperate, just answer it wrong, and that's still better than not giving any answer at all. And we have more. So move on to question 3 and find out more of these syntax errors. Why am I doing so many of them? Because this is just such a common activity that you're going to have to do, find syntax errors. So I wish I could clone this question. But I don't know how to do that. All right. Oh, I need a refresh. All right, let's go through the options of this one quickly as well. So one option was there should have been a semicolon here. And no, that actually would have been a syntax error. That would not compile. There should have been a comma after hello. I guess, that is true. I guess there should have been such a comma, grammatically speaking. But, that's not really what was intended. There should have been a semicolon after the 6th line. 1, 2, 3, 4, 5, 6. This is the 6th line. Yeah, that's got to be it, right? And let's see what people did. And that is, in fact, what they said. Most of them. But not very many. All right, so here I have the first one that's actually a little hard. Oh, I see. That is an interesting question. That was not exactly my intent. So, so in this case, okay, that's not. But yeah, that's a tolerable answer though. All right, let me put it up and let's see what people think. I had not thought of that. So, choices 1, 2, 3, 4.
Yeah, mine just auto refreshed even though I'm still loading my first.
All right.
It's like, how did that work? It's like I can't send the results to the vertical, but it's sending me the vertical. Oh wow, you clicking on that.
All right, now this one here is more interesting because let's first of all eliminate the things that aren't errors. Why is number 2 not an error? It's a comment. You can put anything you want in comment. Why is number 4 not an error? It's a string, and it's properly quoted on both ends, and you can put almost anything into a string that you want. Like what couldn't you put in a string? A quotation mark, right? And so the book tells you what you need to do. If you wanted to put in a quotation mark, you actually have to put in a backslash and then a quotation mark. Another thing that you can't put in a string is you can't just hit enter. If you wanted to have a string that extends over 2 lines, you have to put in this thing into the string. So, but none of these is the case. These are all harmless things. A bunch of zeros, not a problem. Now over here, can you name a class HEL0printer? Actually, you can. Now, a whole bunch of you are going to say, well, that's an unfair question because that was not covered in the book yet. That's true. Life is unfair. So there really, you can't, from what we've covered in the book so far, answer this particular question. But I'm telling you that the name of a class can contain letters or numbers, but not symbols. You couldn't put a comma into a class name, for example, or a minus sign. But letters and numbers are okay. And so this one is okay, provided, as the fellow in the front said, that we've actually saved it in a file HEL0printer. If it was in the file .java, if it was in a file HelloPrinter.java, then that would be an error. So if you checked on number 1, and your rationale was that you thought it was inside HelloPrinter.java, that's a valid choice. Sometimes that's what's going to happen with these clicker questions. I'll put something where there may be more than one valid choice. So depending on your state of mind, that might be a valid choice. But actually, when you look at this one here, that is definitely an error because as it happens, the name of something can never start with a number. And you're going to learn that in the next chapter. Names can never start with a number. So this really is an error. But the truth is, you could fairly say, I had no idea because I wasn't yet asked to read chapter 2. And what do you do in that case? You give it your best guess. And that's fine, right? There's no penalty for a wrong answer. And you should just, you could randomly cross out something, but I mean, that's just that seems a waste. So just give it your best guess, and you'll learn something from the answer. All right, so I have a couple more of these that, in the interest of time, I'm not going to do because I want to give a couple of tips. So tip number 1 is to download the program code so that you have it available. So you want to go to the course web page. Oh, actually, I bookmarked it. Oh, that should be tip number 0. Bookmark the course web page. So book code, worked examples. It is here. Source code. Oh, mercifully, they gave us something that says download all files in zip format for those of us who don't enjoy clicking on 18 links. So we'll do that, and then you save it somewhere and you unzip it. I already did that. Let me show you where I have it. So I just made a directory book, and inside there I put in the code, and now if I ever needed to copy and paste like Hello Printer, then I could just copy and paste it really easily. There are these HTML files here. I don't even know why we give them to you. You don't need them. All right, so that was tip number 1. And you really want to do that because more often than not, there's some program in the book that's kind of similar to the task at hand, to the homework or to the lab. So find it, copy and paste it in BlueJ. And so really, don't type what you can copy and paste. It is not only faster to copy and paste, it is also much less error prone. In particular, during an exam, you're going to be in this situation. There'll be an exam question, and it'll give you a whole bunch of code, or it'll be really similar to something that you already had, because in the exams, there's not enough time to break new ground. It'll always be similar to something. You want to be able to quickly go into BlueJ, have the new class there, blam, 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 paste everything in, and then start thinking about what you really get credit for. So that's a useful skill to have. Now, is it plagiarism? It's not plagiarism. You can use anything from the book. So if for whatever reason no, it's not going to happen. In this semester, everything in the book is fair game. And you don't even have to say it's from the book. I know what's in the book. I wrote it. All right, so do this. Download the program code, put it somewhere on your hard disk. Next tip is to understand the file system. And for some of you, this may be the first course where you're using a computer as a generator of significant content. Maybe until now you used your computer to browse the web and play a few games or something. I don't know whether that's true. But every semester I have a few students who just have never really had a reason to think about the file systems. And who didn't have to think what files are and where they are. And particularly because for 99% of computer users this is not very interesting, Windows hides the structure to help those users out. So many people in Windows put absolutely everything on their desktop. I have seen people where the desktop is covered with files. Now, that doesn't really work for a programmer. Why not? Because your desktop is soon going to be covered with this thing. And particularly when you use NetBeans, which is pretty large, your desktop is going to be completely covered with your development environment, and then you can't see any of the files in it, so what's the use of having a desktop? The other thing that's wrong with the desktop is it's a completely flat structure. If you have two files called bankaccount.java, you can't put them both on the desktop. So you really do need to understand how folders work. So there are a number of folders that you need to be able to find on your machine, and it really depends on what operating system are you using. Are you using Windows XP, Windows 7, Windows 8, Linux, various flavors of Linux, Mac OS? So you need to find out where is your home directory and figure out where it is. Then you need to find out where's the download directory, because so often it'll happen, like in an exam, it might say download this file, and you want to quickly be able to locate that thing. And where is it? There are different ways of setting up your browser. Your browser is the one that does the downloads. Some people have set up their browser so that it downloads on the desktop. Bad idea. You don't ever want to use the desktop for anything. The professional way of doing it is that you make yourself a directory called downloads in the home directory. Maybe it's already there made for you. Some operating systems do, some operating systems don't. Some browsers do, some browsers don't. And then make sure that your browser puts it inside that directory. Then any time that you're looking for a download, you can go into your File Explorer and you can look at the downloads directory. It actually is also a good idea to empty it out once in a while so that it doesn't look like this. All right. So home directory. Inside the home directory, you want to make some subdirectories. So many of you have your own scheme. If you have a scheme, that's great. If you don't yet have a scheme, follow this one here. Make a directory just like I did, called SJSU. Inside that, make a directory CS46A. And whatever you do, when you make a directory name, make sure that it does not contain spaces. There are many tools that do not work well when you have spaces in the directory names. And you're going to find that out quickly enough, particularly the Windows users amongst you, when you're going to struggle with that directory name that was cruelly named program space files. If I had $1 for every time that some student had grief with that, I could retire right now. Make a separate directory. Important. It's important. Make a separate directory for absolutely everything. For this homework, the homework that you're going to be turning in tomorrow, you have to make 3 directories. Now, as it happens, BlueJ will make them for you. If you make 3 projects, it'll make 3 directories. So every time that you make a directory, a project in BlueJ, it makes a directory. Let me really quickly demonstrate that. We had over here, I made a project hello, and good old BlueJ made a directory called hello. So if you make a directory, if you make a project, homework 1A, homework 1B, homework 1C, you're all set. In fact, let me do this in record time. There's BlueJ. So let's call the project homework 1A. What is homework 1A? I don't remember. It's down here. Here we go. Okay. Oh, it's from the textbook. So, but the draft says to print Hello Junior Coder. So which program is it similar to? Well, it's going to be similar to this one. I have to call it Animal Greeter. So new class, Animal Greeter. I don't want any of this. I want my stuff. Okay, I want to print out, what was it? Hello Junior Coder. Just like that. Hello. Notice how I even copied the lines of code that were similar. You know, who wants to type this stuff? Remove the comment. Okay, I have just finished the draft. And now watch this. Now I want to know whether I did it right. Click on this thing here where it says draft. And now take what you've done, paste it in here, and click on Submit Query. And now something magical happens. This thing called NetBrat, that will soon be your best friend, tells you that you did something wrong. What did I do wrong? Yeah, I forgot to name this thing right. So it's Animal Greeter. Yeah, you'll see what I do in a minute. So now I'll paste it in again. And now NetBrat was able to compile it, but NetBrat knows the answer to this question. And now it says, oh, there were 2 errors in here. The junior, it wanted junior, and the coder, it wanted the exclamation mark. So let's fix those, and then I'll let you go. Oh. So, and now NetBrat is happy. And now I'm ready to submit my thing into the Dropbox. So what NetBrat does is it knows what the grader wants to do. In fact, the grader will run a very similar program. Last time around, I said everyone has to use NetBrat. But this time I said that's crazy talk. If you want to use NetBrat, by all means, be my guest. It's there to help you. You don't want to use it, you know, just crawl back to where you came from. It's not my problem. So go ahead. Use NetBrat and have it find the errors that otherwise the grader would find. I'll see you on Wednesday.